Hello everyone, welcome back. So in this video we are going to learn about the next type of continuous time signal, that is unit parabolic function. Okay, so unit parabolic function. If you are first time to my channel, please consider subscribing. Okay, so unit parabolic function, it is also called acceleration function. It is also called acceleration function. So unit parabolic function is defined only for positive values of time, that is t greater than or equal to 0, and it is represented by p of t. So it is represented by p of t, and it is given mathematically as p of t is equal to t square by 2 for t greater than or equal to 0 is equal to 0 for t less than 0. Okay, so if you draw this pictorially with t on x-axis and p of t on y-axis, you will get the shape of parabola. Okay, so it is increasing linearly. Okay, so it is not linearly, so non-linearly it is increasing. So that is the why it is p of t, it is a non-linear function. So p of t is equal to t square by 2. Okay, is equal to 0 for t less than 0. Similarly, the shifted version of unit parabolic function p of t minus a is like this. So instead of starting from 0, now it starts from a. Okay, so this is p of t minus a versus t. So the important point here is the mathematical relationship or mathematical representation of unit parabolic and its diagrammatic representation. Along with that, we have to know the relationship between the three type of basic signals, that is step, ramp and parabolic inputs. Okay, so unit parabolic function. So unit parabolic function is obtained by integrating. So it is obtained by integrating the unit ramp function. Okay, so by integrating the unit ramp function, we'll get this unit parabolic function. Similarly, double integrating. So double integrating unit step function, double integrating the unit step function, also you'll get the unit parabolic function. So if you write it this in mathematical form, we'll get it as p of t is equal to integral r of t dt, because integrating unit ramp function you'll get the unit parabolic function. So p of t is equal to integral r of t dt is equal to double integral 2 times integral u of t dt. Okay, so this is the relationship between p of t, r of t and u of t. Similarly, if you write the reverse relationship, that is unit ramp function is obtained from derivative of unit parabolic function. Similarly, unit step function is obtained by double derivative. So double derivative of unit parabolic function. So if you if you take the double derivative of unit parabolic function, you'll get the unit step function. So if you represent it mathematically, r of t is equal to d by dt of p of t, and similarly u of t is equal to d square, that is double integration d square by dt square of p of t. Okay, so this is the relationship, and this is also the relationship between r of t, u of t and p of t. Okay, So next we'll discuss about singularity functions. Singularity functions. Singularity function. Any function which does not have higher order derivatives. So any function which does not have higher order derivatives are called as singularity functions. So that type of functions are called as singularity functions. Okay. So for example, if you take a ramp function, that is r of t. If you take a ramp function r of t, then its second order derivative, so its second order derivative is maximum. Because r of t first derivative will gives you u of t, and u of t derivative will gives you the impulse function. So we'll discuss about this impulse function later, and derivative of impulse function is always equal to 0. So derivative of impulse function is always equal to 0. So if you take here ramp, so the second order derivative is maximum. So first derivative is u of t and the second derivative is del of t. So this is the highest derivative present for a ramp function. So its second order derivative is maximum, and hence its higher order derivatives are not having, that is its value is equal to 0. So this type of function is called as singular or singularity functions. Okay, so ramp is a example of singularity functions. Similarly, step and parabolic inputs, or parabolic functions, or parabolic inputs or functions are also singular. So they are also singularity functions. And suppose if you take e power t, so its derivative is e power t, and again if you take derivative you will get e power t. So it continues up to infinity. So if you take this, it will come, the derivative is obtained infinite number of times. So it is having the higher order derivatives. Now it is having the higher order derivatives, and all the derivatives up to infinite order is present for the function e of t. So it is not singular. It is not singular function. Okay, one more example is cos t. So for cos t, if you take derivative, you will get sin t irrespective of this sign. Okay, so plus or minus, maybe the derivative is present or not is important, but not the sign. So again sin t will get cos t, for again cos t will get sin t, and so on. Okay, so you'll get infinite number of times. So this cos t is also not a singular function. Not a singular function. Okay, so any function which does not have the higher order derivatives are called singular functions. So ramp, step, parabolic are the examples. Parabolic functions are the examples of singularity functions, whereas e power t and cos t are the examples of non-singular functions. Okay.